let's solve a two-step equation. Let's say we have a number x and we multiply that by 2. Whatever that is, we're going to add it to 1. The answer is going to equal to 9. So what is x? What number multiplied by 2 then added 1 equals to 9? So to solve this algebraically, we're going to get x by itself. So the first step is to always do the order of operations backwards. Since we added 1 last, we're going to do this one first. We're going to subtract 1 both sides because that's the opposite of adding by 1. So now we have 2x. But 9 minus 1 has to equal 8. And again, if we subtract 1 from the left side of the equal sign, we have to do the same thing to the right side of the equal sign. So 9 minus 1 is 8. And there you go. So that makes sense because 2x has to equal 8. 8 plus 1 has to be 9. So it makes sense that this whole thing is actually equal to 8. Okay, but what is x? A number doubled is 8. What's the opposite of timesing by 2? The inverse operation of multiplying by 2 is in fact dividing by 2, both sides. That way, 2 divided by 2 is 1. And 8 divided by 2 is now 4. And there you go. Let's go ahead and double check if that makes sense. 2 times x, which is 4. 2 times 4 is in fact 8. And 8 plus 1 is in fact 9. So this makes sense. So that is solving a two-step equation. Here's another example. Let's say we have a number x, but this time I'm going to triple it, or timesing by 3. Afterwards, I'm going to subtract it by 2, and the result is 10. So what is that number? Now to solve for x algebraically, we're going to isolate the variable x. Let's go ahead and get x by itself. So we're going to undo the order of operations. Since we did the minus 2 last, we're going to deal with this first. So what's the opposite of minusing by 2? The opposite of minusing by 2 is to add by 2 both sides. So negative 2 plus 2 is 0. But again, if I add by 2 here, we must add by 2 there to make sure the equation is balanced. So now the 3x comes down, and then 10 plus 2 on this side must be 12. Now, what's the opposite of timesing by 3? The opposite of timesing by 3 is to divide by 3. And again, we have to do that to both sides of the equal sign to make sure the equation is balanced. So 3 divided by 3 is now 1. And so 12 divided by 3 is in fact 4. So let's just double check that the answer must be 4. 3 times 4 is in fact 12. But 12 minus 2 is also 10. So the answer x equals 4 checks out. Let's do another example. We have a number x multiplied by negative 3. Then we took that result and added by 10, and the result is equal to 16. So we're going to isolate for the variable x. Now to isolate the variable x again, we're going to do the order of operations done to x backwards. Since we added by 10 last, we're going to go ahead and do the opposite of adding by 10, which is to subtract by 10 both sides of the equal sign. Then we got negative 3 times x equals 16 minus 10, which is in fact 6. Okay, so now we got to figure out what's the opposite of x multiplied by negative 3. The inverse operation, or the opposite of timesing by negative 3, is to divide by negative 3 both sides. That way, negative 3 divided by negative 3, two negatives when you divide them each other makes a positive 1x. And 6 divided by negative 3, this time we only have one negative. 6 divided by 3 is 2, but since we only have one negative, it's a negative 2. Let's go ahead and double check if the solution is correct. Negative 3 multiplied by negative 2. So what happens if I do negative 3 times negative 2? Well, negative 3 times negative 2, when you multiply two negatives, makes a positive 6. So this is 6. but 6 plus 10 is in fact 16. So the solution of -2 checks out. Let's try another example. Say we have another number x, but this time we divide that by 5. We took that result and we subtracted by 4, and the result is 1. So again, we're going to isolate the variable x. To get x by itself, we're going to undo the order of operations done to x. We took x divided by 5 and then we subtracted by 4. So we're going to do the opposite direction. We're going to deal with the -4 first and deal with the divided by 5 last. So what's the opposite of subtracting by 4? The inverse operation of subtracting by 4 is to add by 4 both sides of the equal sign. That way we have x divided by 5, but on this side we got 1 plus 4, which is 5. And now we're almost done. So now we have to somehow get rid of something that says divide by 5 to get x by itself. So what's the inverse operation, or the opposite of dividing by 5? Well, the opposite of dividing by 5 is to multiply by 5 both sides of the equal sign. 5 divided by 5 is just 1. That's why we only have 1x. But 5 times 5 on this side is 25. And that's our solution. Let's just double check to see if that actually works. If we plug in 25 into x over here, 25 divided by 5 is in fact 5. Then 5 minus the 4, 5 minus 4, is in fact 1. So the solution 25 checks out.